So I'm just going to do a quick recap of junior cert coordinate geometry of the line. Okay, so the first thing you know is distance, and that's just your distance formula in the log tables. Okay, or they could ask for the length of the line, or they could ask for the distance between the points A and B. Okay, next is midpoint. So that's just finding the middle point between 2 points. Okay, and then we have slope. So there's a little bit more to slope. So there's 3 ways you can get slope. First way is using your formula y2 minus y1 over x2 minus x1. Or if you're given a diagram, you can use rise over run. Or if you're given an equation, you can use y equals mx plus c. And m, the number with the x, is your slope. Okay? Now, a positive slope, a line will go like that. A negative slope, the line will go like that. Okay, so this will be a plus, your slope, your m, and this will be a minus. Okay? Parallel lines have the same slope. Okay, m1 equals m2. Perpendicular lines, they have opposite slopes. Okay, what that means is you turn it upside down and change the sign. To show that two things are perpendicular, you do m1 by m2 equals minus 1. Okay, so you're going to multiply the two slopes and your answer should give you minus 1. If it does, then the two lines are perpendicular. If the two lines are parallel, then your first slope should equal your second slope. Okay? The fourth thing we have is equation of a line. And we have two different equations. So y minus y1 equals mx minus x1, and this is given to you. Or we have y equals mx plus c. Okay? To use this, you need to have a point, a slope, and then the formula. Okay? To use this, you need to have the slope, and you need to have the y-intercept. Okay? So this point C is where it cuts the y-axis. Okay? And we know from earlier, m is the slope. Okay? Now, normally if you're given a point and the slope, you'll use this formula. Generally, they'll give you an equation and they're asking you for the slope or the y-intercept. Okay? So, for example, write down the slope of 3x minus 2y minus 9 equals 0. So if they're asking you for a slope and they've given you an equation, you need to write the y on its own. Okay? So you're just going to bring the y to wherever it'll be positive. 3x minus 9 equals 2y. You don't want 2y, you want y on its own. So you need to divide everything by 2. So that's going to be 3x over 2 and minus 9 over 2. So now you can see that the slope here is the number with the x, so that's 3 over 2. Okay? And if they asked for the y-intercept, that would be minus 9 over 2. Okay? This question is if they're giving you 2 points and they're asking you to find the equation of the line, or they're giving you 1 point and the slope. Okay, so find the equation of minus 1, minus 2, and 2 minus 4. Okay, so I know if I want the equation, I need 1 point, slope, formula. I have 2 points, so I can just pick whichever one, and I need the slope. So slope is y2 minus y1 over x2 minus x1. Just label these x1, y1, x2, y2. Then to get the slope, it's going to be y2 minus y1 over x2 minus x1. Okay, so my slope is minus 4, minus by minus is plus 2, so that's minus 2 there. And 2 minus minus 1, so that's 3. Okay, so minus 2 over 3 is my slope. Now I can just pick one of the points and fill it into my formula. Excuse me, so my formula, I'm just going to use this one because it's already labelled x1, y1. My formula is y minus y1 equals m x minus x1. Okay, you'll notice I've put the bottom of the fraction on the bottom line. It just makes it a bit easier to see where that 3 is supposed to go. So it's at the bottom of one side, it's going to go to the top of the other. So it comes out here and gets multiplied. Y, now minus by minus is plus 2. That 3 has moved up, so it's no longer there anymore. Just the 2 there beside the bracket, and minus by minus is plus 1. Okay? Now from there, you just tidy up and you bring everything to one side. So 3y plus 6 equals minus 2x minus 2. And I'm bringing everything over there. 3y plus 2x plus 6 plus 2 is plus 8 equals 0. So that's the equation of that line there. Okay? Now, a few other things. Often they like to just give you some information. So they might say find the equation of the line through minus 2, 1, which is perpendicular to the line 3x plus 2y minus 4 equals 0. Okay, so they're asking for equation of a line. So you know you need point, slope, formula. I definitely have a point. There it is, minus 2, 1. The slope, however, I don't have yet. So I know I'm looking for a line that's perpendicular to this line. I know perpendicular lines have opposite slopes. So if I get the slope of this, I can get the opposite slope. So in order to get the slope of this one, I need to get y on its own. So move everything over there. 2y is minus 3x plus 4. And then I need to divide it all by 2. So I know the slope of this line is here, minus 3 over 2. That means the perpendicular slope, turn it upside down and change the sign, 2 over 3, and it would be a plus. Okay, so now I have my point, minus 2, 1, and I have my slope, which is 2 over 3, and then I can fill it into my formula. Okay. The last few things are about how do you sketch a line. Okay, so to sketch, you need 2 points. Often, the easiest points are let x equal 0 and then let y equal 0 and get 2 points. Okay. When you're graphing, if a line is vertical like that, okay, at any point on that line, the x stays the same. So x equals, for example, 1. If it was here, x equals 2, x equals 3. If you have a horizontal line, anywhere on that line, y equals something. So y is the same thing anywhere along that line. So in this case, let's say y is minus 3. Okay. If you want to investigate if a point is on a line, what you're going to do is you're just going to fill in the point instead of x and y. Okay, and then when you do that, the left side should equal the right side. Okay, and if it does, then the point is on the line. If the left side doesn't equal the right side, then the point is not on the line. And the last thing is to find where two lines intersect, you're going to do simultaneous equations. Okay, and that's it for coordinate geometry of the line.